What's up, y'all? I'm Sean, the owner and lead tutor of Math Swap Tutoring, and I want to talk about um, what an engineer actually does. And I'm going to talk about it from the standpoint of my personal experience. So I have over 14 years of active experience in the area of electrical or electronics engineering, rather. And so I'm just going to tell you how a typical day went for me. All right, so typically coming into the job, well, let me say this. Engineering is indeed very different, whenever you go to engineering school, between that and whenever you're actually working in the field. Totally different. When you're in school, it's all about theory and all the background behind it all. You do have some level of application, but when you get into the field, it's going to be a lot different. So that said, a typical day for me was, coming into work at whatever time, 7. It was earlier at some point, but come in to my cubicle. I had, a little cubicle, had, one or two computers. I log on and, check my email. I might have something to attend to that the project manager sent me, or maybe one of the other stakeholders that we work with, what they sent me. And anyway, after that, might eat your little breakfast or something like that you brought in. But as far as like the practical work is concerned, a lot of times I was working on something. Like I might be working on like some code to try to troubleshoot software for in my case, for like something like a tester that's supposed to test some sort of electronic equipment. So I would, get to that, whatever phase of the project I was in. Like if I was actively working on the code, I might, at that point go and open up the code and investigate the problem. I'm looking at, the issue that the user of the code or the user of the program was having. And so I'm actually going into the code and looking at that particular part of the code, trying to find out where the issue is, to see if the issue that the user is having is either like a user error or an actual software problem, like a bug, in other words, a bug in the software. And so if I've determined that it is a bug in the software, then what I would be doing is I would actually be going into the code and trying to figure out different ways of implementing the code, whether I change the code or add something to it, to make it work better. And so then, so if I'm in that phase of engineering, and that's what I was working on at that moment, but if I'm already past that phase, I could be going down and talking to the user and, kind of like picking their brain to kind of see what they need, or, more details of the issue that they're having. I could be going to our laboratory to actually test potential changes to the software, potential alterations to the software, running like a either like a mock-up or like some sort of like digital way of testing that doesn't require like a mock-up. When I say a mock-up, a lot of times if you have like some sort of software that's running hardware, a mock-up is essentially like a little setup where you can test this hardware in like a quote insulated environment. It's not quite real world type of situation, but what happens is you're testing like a condensed version of that hardware that you have in your own laboratory, where you can kind of test it and you can kind of insert different kind of conditions, like let me like simulate this issue, that issue, so I can get it to go to that part of the code and see if the hardware is actually working, that type of deal. So yeah, I might be doing that as well. I could be working on a document for that day. So part of engineering for me was, it often involved writing up documentation. Now, you may be surprised as somebody who's looking to be an engineer to understand that writing documents sometimes is a part of what you do. But it is, because a lot of times you kind of have to either explain what you're doing to the code or what you did to the code, or you have to create documents that are just a part of the process. So a lot of times as an engineer, in my case, I would have to, after I investigated this issue that the user of the software presented, I would have to do what's called a report of findings. So I would have gone in there, done my investigation, and I would say, okay, this is what I found, and this is what I believe the fix is going to be, you know. And so then after I, submitted that report and it got approved and all that kind of stuff, through, a series of, emails and whatnot to the user and to the customer, then I would have to go in and fix it, implement the fix. And once I confirmed that the fix worked, then I would have to go back and essentially arrange for what we call like sell off, where you actually have implemented the change. You officially put it into the previous version of the code. You have to do it in a very special way so you don't break everything. You can't just work from some sort of version that you have on your computer or somewhere else. You have to go from an official copy of the code so that you don't inadvertently add something to the code or subtract something from the code because you were using like some sort of working version. Then you have what's called sell off, where you literally have to have like the customer and the user to come to a meeting that you essentially organize, and you demonstrate that your code has fixed the problem. And then once you do that and everybody signs off, and that project is done. Now, sometimes it could be that the fix that you thought was going to fix the problem doesn't fix it. And you go to the sell off and you're demonstrating this as an engineer, and then it still doesn't work. Maybe something happens weird that day and it looks like your code is not working. And so then that means that the sell off is called off and you have to go back to the drawing board and try again and redo your fix. So the nature of the engineering that I did in that part of my career was not necessarily a from the bottom up writing a whole lot of code. For me, it would be like a lot of times troubleshooting issues with software and then rewriting portions of software, or even just adding small fixes to portions of software to help stuff work properly. So that's the nature of what I did. Now there was, there's a couple of opportunities I had where, I was able to travel. Yes, we did have a lot of meetings. Sometimes quick, stand-up meetings where we would, every day kind of get up and the whole engineering team, which comprised of engineers, engineering technicians, project managers, supervisor, we had to get up and give status on what we were working on in front of everybody. And then sometimes we have to do that with the other stakeholders, with the user of the software that we created, so they could hear our progress on what we're doing and all of that type of stuff. So that's kind of like some of the nature of what I did. Now, did we do active math calculations and stuff like that? Usually, no. Very rarely did I actually have to go in and kind of pull out a calculator and kind of do some sort of quick math that I did in college. And the reason why I didn't have to do that is because in this day and age, in the 21st century, it's not usually necessary for an engineer to have to go as deep as you do in college, doing calculus and all that type of stuff. I mean, it could happen, but usually the area you're going to see that in is if you're doing engineering, research, and development. So that I did not do that. When you're developing new products and whatnot, that's when you'll do that type of thing. But I didn't necessarily work on anything that was totally new. I might work on like an upgrade to some sort of hardware or software, but usually it still only required that I actually work on integrating something into an existing system. Okay. So engineering in the real world doesn't typically require a whole lot of like math and stuff because it's already in the software that you work on. I did have to code, and I coded in C#. I also did I helped at one point in my career do like graphical user interfaces, which was kind of like a not coding like typing in words and stuff like that, but it's kind of more so using like a visual type of way of coding. But anyhow, so that's kind of like a day in the life for me as an engineer. And again, that may not necessarily be how it is in every area. I worked in aerospace, so but it may not be like it was for me for every engineer. because you also have engineers who just do quality control. You have engineers who do testing only. You have engineers who do research and development. You have engineers who maintain and sustain, like I did. So it's a lot of different areas that engineers can work in. And then you also have, like, the different industries, like I say, aerospace, or power generation, audio, video, so many different areas. So, hopefully me talking about what I did kind of helps you to see a little bit of how engineers work, in case you were curious. So hopefully that helps you. Hopefully it gives you a better idea.